Hi, this sample problem video is to help you understand how to complete specific heat capacity problems. I have a couple of problems here to show you. First one is how much energy is required to heat 1.3 grams of iron, which has a specific heat capacity of 0.107 calories per gram degrees Celsius from 25 degrees to 46 degrees Celsius. Now, all of these problems use the formula Q equals mCp delta T, where Q is heat, measured in calories usually, M is mass, measured in grams, Cp is specific heat capacity, measured in calories per gram degree Celsius, and delta T is the change in temperature, measured in degrees Celsius. Now, for all of these, I recommend that you list out each of these four variables. And in each problem, you will always be given three of the four variables, and you have to solve for the one that's not given. So let's go back through again and enter things in as we see them in the question. So how much energy? Energy. So that's our unknown. Q is our energy because that's heat. Heat is a type of energy. So there's our unknown. Is required to heat 1.3 grams. All right, so we got to use that unit, grams, in order to figure out which one of these it goes with. All right, so grams is the unit of mass, and M is mass. So I therefore know that that goes there. Here it says, which has a specific heat capacity of. Now this tells me that this is the specific heat capacity, and some problems do that, making it a bit easier. All right, but either they give you the units and you figure it out, or they just tell you what it is and you enter it in. And then delta T, remember, is the change in temperature. And usually, basically, what you do is you take the larger one and subtract the smaller one. So we go 46 minus 25, and that gives us 21 degrees Celsius. Now, the next step is, once we have all that, we want to make sure that our unknown is isolated in the problem. Here it's already isolated, so no problem. We just go M is 1.3 grams, Cp is 0.107 calories per gram degrees Celsius, and delta T is 21 degrees Celsius. I go through, since they're all next to each other, that means I simply multiply. So I got 1.3 times 0.107 times 21. Now my calculator, I have 2.9211. But I look at all the numbers that are given, and the fact that these two have only two significant figures, that means my answer needs to be rounded off so that it also has only two significant figures. Remember, the answer must have the same number of significant figures as the measurement with the fewest. So to round this off with only two sig figs, I'm going to keep the 2 and the 9 and cut it off or round it off after the 9. That 2 is not large enough to round the 9 up. Remember, that needs to be a 5 or greater to do that. So my answer is simply 2.9, and the units of Q, if you notice, grams cancels out, degrees Celsius cancels out, and that leaves calories. So that's the units there. And there's my answer. Now the next problem's a bit more, bit trickier, but still totally doable. Again, I'm going to list out Q, M, Cp, and delta T. All right, that over. And I know I'm going to use the formula Q equals mCp delta T to start off. Now here, it's asking for the specific heat capacity. So I know that is going to be my unknown. And it says of a substance that requires 49.7 calories. Now I know calories is a unit of heat. Q is heat. So I know that 49.7 calories goes there. To raise the temperature of 9.82 grams, since that's grams, mass is the unit, mass has grams as a unit, therefore, I know that 9.82 grams goes there. And then finally, I have my two temperatures. Again, I subtract the smaller from the larger, so that's 64.7 minus 13.9, and I get 50.8 degrees Celsius as my delta T. Now back to here, since CP is my unknown, I have to isolate CP. Now, in order to do that, I'm going to rearrange it while still in letter form. It's so much easier this way, trust me. Now, currently, delta T and M are being multiplied by CP. To isolate an unknown, I simply do the opposite of what's being done to it. Since these guys are multiplying CP, I want to go and divide by M and delta T. All right? Since they're multiplying it, I want to divide by them. That way M cancels, delta T cancels, and that leaves me CP all by itself. Now, of course, because of the equal sign, I need to maintain balance. What you do to one side of the equation, you have to do to the other. So I end up with M and delta T being divided on the other side. So there's my equation. CP is equal to Q on top and then M delta T on the bottom. Once I have the unknown isolated, I simply plug the numbers in. Q is 49.7 calories. M is 9.82 grams. And delta T is 50.8 degrees Celsius. And since I have two numbers on the bottom, one on top, remember the rule is if the number's on top, you multiply, numbers on the bottom, you divide. So on my calculator, I simply go 49.7 divided by 9.82 divided by, since it's on the bottom, 50.8 equals. And I get, on my calculator, 0.0996279. Well, I look at all the numbers that went in. Each of these guys have three significant figures. So I want to take my answer and round it off after the third significant figure. The zeros in front are not significant. So I need the 9, and the 6, and I round it off after the 6. The 2 is not big enough to round the 6 up, so my answer is simply 0.0996, and then the units, none of these cancel out, so that's calories on top per gram degrees Celsius. And there's my answer. I hope you found this useful. Please ask me for help if you need it. Good luck.